Hello. Right, we are back again with some more adding fractions. So, carrying on with sort of where we left off a little bit last week. So, we are adding mixed numbers again. And whereas last week we had to, for example, do something like this. So if you remember, we had our two mixed numbers last week, but our denominators were the same. But we're not going to do that today. We instead are going to have denominators where they are different. So I'm going to change this to that fraction. So now our denominators are not the same. But this is sort of in between, because those of you who remember might have already noticed that these two are quite nice denominators actually. And actually, do we need, when we start doing some stuff in a minute, are we going to have to worry about changing both fractions? No, we're not. So, first job is converting our fraction into a mixed number. No, that's a lie. We're going to convert a mixed number into an improper fraction. So we should remember improper fractions are when we have a number that is larger on top. Like these two, for example. 15 is larger than 10. 7 is larger than 4. That's what we're going to do. These are friendlier to work with. So, this one over here, I'm going to ask myself, what is 3 times 1? That is 3. I then add my 1, and I end up with 4. And I keep my denominator the same, 4 over 3. And again, just like we were doing last week, an opportunity for a diagram. So I'm going to draw these two out, split them into thirds. So we've got one whole here. So we're going to shade all these 3 in, because these represent one whole. That's one whole amount. And then this here is 1 out of 3. It's like part of it. So we're just going to shade 1 in here, because this model here represents 1/3. One of the 3 is shaded. So this diagram is saying 1 1/3. And then if you look here, my improper fraction, which is the exact same as this, just looks slightly different. If you remember, we did fractions. We said that Ant and Dec are Ant and Dec, whether they are wearing suits, whether they're wearing sailor hats or cowboy hats. Ant and Dec are still Ant and Dec, they just look slightly different. 4 over 3, because 1, 2, 3, 4 bits are shaded. The exact same. They all represent the same thing. This one over here then, same as what we've done over here. We're going to do 6 times 2, which will give me 12. And then 12 plus 2 gives me 14. And I keep my denominator the same, which is 6. So I can work with these now. These are okay to work with. So you'll notice here with our denominators, we've got a 3 and a 6. And again, thinking back to when we've done bits and pieces with fractions before, earlier in the year, do we need to change both of these around? No, we don't. This one, we're going to keep the same, because we know that we can make this over 6 also. So, I'm going to do a little line here. Okay, because I know 6 is a multiple of 3. So how do I get from 3 to 6? Well, I times it by 2. Therefore, whatever we do to the bottom, we have to do to the top. And the same way around, whatever we do to the top, we would do to the bottom. Oh dear. So therefore, if 3 times 2 is 6, 4 times 2 is 8. So we've got these fractions here, now both equivalent fractions, but you'll now notice that these are both now over the value of 6. So we can add these two together now. So just like before, now these two are both the same. We're going to keep the denominator the same. And now all we have to add together is 14 and 8. So that's going to give us 22, like so. Now, just like last week, we cannot leave this fraction in improper form. See if you can remember why. Because if the question has got mixed numbers in it, the answer must also have a mixed number in it. So we can do this. We're getting good at this. We're getting practice. Practice makes perfect. So 6 is my denominator. I'm thinking about multiples of 6. I'm just going to pop some of these up here. 6, 12, ooh, whoops, 18, 24. Okay. So again, 22 and 6. The closest we're going to be able to get is going to be 3 wholes, because 6 times 3 is 18. And then we put our denominator down here. We keep the denominator the same. We have to sort of write how many is left over now. So we're sort of saying to ourselves, well, what is 22 take away 18? Oh, that is 4. So therefore, I'm going to write 4 here. So I'm now left with 3 and 4 6 as my answer. But there's one final thing for this question. What can we do to this fraction to make it in its simplest form? Our simplest form. So you might have noticed this here, we can do something to this fraction. We can simplify this fraction. So, thinking about what we know about our numbers and all our number facts, I know that I can divide both of these numbers by 2, which would leave me with that. So my final answer in the end will be 3 and 2/3. This answer is right, this answer is right, and this answer is right, but this here is the most ideal answer. That is the simplest form, a mixed number, perfect answer. And if you get answers like this and this, if you get to this point, that's amazing. Try and get to this point next time. If you get to this point today, but you forgot to simplify, try and do it next time. Okay? Good luck, everybody.